Today's lesson is Unit 2, Lesson 9, Radicals with Variables. So in this lesson, you are thinking about the different radicals that we've learned about so far. So just with perfect squares or simplifying square roots, we're trying to figure out what number times itself equals the number underneath the radical. So for example, for the square root of 4, I know that the square root of 4 is really 2 squared. 2 times 2 equals 4. So 2 squared, if you think of that as being a perfect square, there's 2 of them, 2 of the 2's, so then the square root of that is 2. Square root of 9 is really the same as the square root of 3 squared. The square root of 3 squared equals 3, because we were able to figure out that 3 times itself equals 9. The same process works with variables. With x squared, or the square root of x squared is a perfect square because there's 2 of them. So the square root of x squared would just be x. If I have an odd number, so the square root of x cubed, you can think of that as being the square root of x squared times the square root of x. So x squared is a perfect square, so the square root of x squared is x, and then I still have this x on the inside, so as part of my answer I would have x times the square root of x. So I have 1 left over. X to the 4th, so square root of x to the 4th. I'm trying to think what number times itself is going to equal x to the 4th. So you're looking for pairs of numbers. So with this, you could think of this as being x squared times x squared. So we're multiplying x squared times itself to get x to the 4th. So the square root of x to the 4th is equal to x squared. Just another look at the patterns that they have. If you have an odd exponent underneath the radical, so this one we have the square root of x cubed, this one square root of x to the 5th, notice how both of those answers still have a number or a variable underneath that radical sign. So they have something on the outside for however many perfect square values there were, but there's still that x inside the radical. When that exponent is even, then it's a perfect square because there's something times itself. There's an even number of pairs. So x squared equaled x. X to the 4th was equal to x squared, and x to the 6th is equal to x cubed because it's x cubed times x cubed. That's what equals the x to the 6th. So another pattern that you might notice, some of you may have discovered already, when you're trying to figure out the square root of these, since it's a square root, your answer is going to be the exponent in half. So x squared, there's 1 left over. X to the 4th, you cut that exponent in half, your answer is x squared. X to the 6th, cut that exponent in half, your answer is x cubed. The same kind of pattern kind of works with the odd ones, except you're going to subtract 1 off, because this would be like x squared times the square root of x. So the square root of x squared times x, the square root of x. The square root of x squared is the perfect square, so that's where we get this x from. And then we still have the square root of x left over. This one, you can think of this as being the square root of x to the 4th times the square root of x. Well, square root of x to the 4th is a perfect square because it's even. So this comes out to be x squared. And then we still have that square root of x left over. So let's try this with a couple more examples. The square root of x to the 12th. Since this is an even exponent, I'm trying to think what times itself equals x to the 12th. So x to the 6th times x to the 6th would be how you get to x to the 12th. Because it's like x to the 6th raised to the 2nd power. It's multiplying it times itself. So this one, you can also think of it as dividing that exponent in half would simplify to x to the 6th. because you multiply x to the 6th times x to the 6th, and that's how you get the perfect square x to the 12th. In the second example, we have x to the 19th and y to the 7th underneath this radical sign. Both of those are odd, so I know in my answer, part of my answer, I'm going to have both an x and a y still inside that radical sign because it's an odd number. And if I subtract 1 off, representing the 1 left over of each of those, you'd have x to the 18th. Hang on, let me write that a little bit better. You would have the square root of x to the 18th times y to the 6th, and then we multiplying that times the square root of xy for the two remaining ones that aren't perfect squares. And then this would simplify to square root of x to the 18th, since it's a perfect square. The opposite of that then is x to the 9th. Y to the 6th, even perfect square, half of that, so y to the 3rd. And then you would still have this xy left over inside your radical sign. So this would be how it simplifies. And then you can combine all of this with numbers. So we've already learned how to simplify radicals if it's a number. Just think of this as being the square root of 16 times the square root of a to the 5th. Well, square root of 16 is a perfect square. That's equivalent to 4. Square root of a to the 5th, since it's odd, I know I'm still going to have an a left over inside my radical sign. Subtracting 1 off is 4. So a to the 4th means that I have a squared on the outside, because a squared times a squared equals a to the 4th. And then one last example with this, simplifying this one. This is 2 times, so think of it as 2 times the square root of 150, and then times the square root of p to the 18th, since it's even, and then q to the 3rd. Since it's an odd number, I have a perfect square in there, so times q squared, and then there's still just one q left over, and then you just simplify each chunk. So 2 times 150, if I break that into perfect square factors, would be like the square root of 25 times the square root of 6, because 25 times 6 is equal to 150, and 25 is a perfect square. And then these would simplify to 2 times 5 times the square root of 6. Or 2 times 5 is 10 square root of 6. And then simplifying this one down, square root of p to the 18th is p to the 9th. And then times q squared, it's a perfect square. So we q times q to get q squared. So the square root of q squared is q. And the last one, just still having q inside our square root. The final step is just writing it all together. So anything on the outside, this 10 p to the 9th and q would stay on the outside. So 10 p to the 9th and q times the square root of, there's a 6 still in there and a q, so times 6, the square root of 6q. And that would be your answer.